Hello May, welcome to MechMinds. In this video, we'll talk about the electrochemistry of redox reactions and how that relates to the specific question you had about the three-cell arrangement. So let's take a look at your question. So here's your question. It's three different cells, cell 1 having tin and inert electrode, cell 2 having two copper electrodes, and cell 3 having a graphite-graphite electrode. The two parts of the question were to find the mass of copper deposited in cell 2 and the color in the pH solution in cell 2 and 3. So what we were given was the amount of tin that was removed from the electrode in cell 1, and I believe that was about 0.034 grams. So this looks confusing because there are three cells instead of two, but the best way to deal with these problems is to look at two cells at a time, because essentially what's happening is the electrons are flowing through all the three cells, and the same number of electrons would flow through all the three cells. You can't have different number of electrons flowing through the different pairs of two cells. So to make this clear, just look at two cells at a time and solve the problem going forward that way. So here we just look at cell 1 and 2 because we're given information about cell 1 and how much tin that gets out of the electrode in cell 1. So let's take a look at what reactions are happening in both of these cells. Specifically, we'll take a look at the oxidation reaction in cell 1 and the reduction reaction in cell 2. So in cell 1, the tin gets oxidized to tin plus 2 ions and leaves behind two electrons. So essentially what's happening is from the tin electrode in cell 1, tin is getting oxidized to tin plus 2, and the electrons released in this process are going through the wire into cell number 2. Now when the electrons reach cell number 2, the reduction reaction takes place. In the aqueous solution of cell number 2, which has copper ions and sulfate ions, the copper ions will accept the two electrons released by cell number 1 and reduce the copper ions in the solution to copper. And what the question is asking us is how much copper from the copper ions in cell 2 get deposited on the electrode. So our task is to find the amount of copper in cell 2, so the second reaction on this slide. Let's take a look at cell number 1 first, the oxidation reaction of tin. So as I mentioned before, tin goes to tin plus 2 ions. So tin from the electrode actually goes into ionic state and forms two electrons in the process. Now this reaction shows that 1 mole of tin gives us 1 mole of tin plus 2 ions and 2 moles of electrons. So essentially 1 mole, because the coefficients in this reaction for tin is 1, so 1 mole of tin will produce 2 moles of electrons. Now we're given that 0.034 grams of tin actually get into the solution. To find out the number of moles of tin that actually go into the solution, we divide this mass by the molar mass of tin, which is 118.7 grams. So the number of moles of tin produced, what I actually mean over here is number of moles of tin going into the solution is 0.034 over the molar mass of tin, which is 2.864 into 10 to the power negative 4 moles. Now this reaction equation shows that 1 mole of tin produces 2 moles of electrons, so we should have twice the number of moles of electron as the number of moles of tin going into the solution. So the number of moles of electrons will be 2 times as the tin going into the solution, so 2 times of the above number would give us 5.729 times 10 to the power negative 4 moles. This is the number of moles of electrons that are going from cell 1 to cell 2 in this particular case, because we were given that only 0.034 grams of tin is going into the solution. Now let's take a look at cell number 2. Since we know the number of moles of electrons coming into this cell, this reaction shows us that for every 2 moles of electrons we get 1 mole of copper. So we already know how many electrons how many moles of electrons we are getting, which is 5.729 into 10 to the power negative 4. And if we divide that by 2, because every 2 moles of electrons gives us 1 copper mole, so if we divide that by 2, we'll get the number of moles of copper that are actually deposited. So we divide that number by 2, we get 2.864 times 10 to the power negative 4 moles of copper. Now we know the molar mass of copper, it's 63.5 grams, and if we multiply that molar mass by the number of moles, we get the number of moles of copper deposited. So in the end, we have 0.0182 grams of copper deposited for 0.034 grams of tin going into the solution in cell number 1. Hopefully this was clear. So this is your answer to part 1 of your question. Let's take a look at your part 2 then. So we're asked about the pH in this case. So as you can see, in cell number 2, what's happening is the copper ions from the solution are getting deposited on the copper electrode. So the cathode is getting copper ions deposited. At the same time, the anode, which is also copper, is also losing copper ions. So essentially there's no change in copper ion concentration. The amount of copper ions going from the solution into the cathode are getting replenished by the same number of copper ions going from the anode to the solution. So a thing to note over here is that copper sulfate solutions are blue in color, especially aqueous copper sulfate solutions. So since there's no change in the copper ions in this case, the color of the solution will not change. And the pH, which is the negative log of hydrogen ion concentration, will remain unchanged because the hydrogen ion concentration had no change in this whole reaction. So in cell 2, no change in pH, the color remains blue. In cell 3, however, the copper ions from the solution are getting reduced at the cathode to become copper, the graphite cathode. However, unlike in cell number 2, we do not have a copper anode here, we have a graphite anode. So there are no more copper ions getting replenished. So the blue color of the solution will fade because you have less and less of copper ions. Also, since we need to complete the reaction now, the Cu2 plus ions in the solution are going to the cathode, we need to have a reduction reaction as well. So what happens is the hydroxyl ions, the OH minus ions in a solution get reduced, and you have oxygen that comes out at the anode, which eventually produces hydrogen ions, 4H plus ions. So in this case, since we're producing hydrogen ions, then the solution will get more acidic, which means the negative log of hydrogen ion concentration would actually go down. So cell 3 solution color changes and the pH goes down. Hopefully this video explained the confusion you had. Thanks again for using MechMinds.